5.9 connecting f prime, and f double prime. For the function f of x equals 2x cubed plus 4x squared plus 2x, use a table to help you organize and draw conclusions. First, we had to find the derivative of this function, which is 6x squared plus 8x plus 2. Then we had to find where it equals 0. So it equals 0 at x equals negative 1/3 and x equals negative 1. X equals negative 1/3 and x equals negative 1. And then we had to find the second derivative, which is 12x plus 8, and that equaled 0 at x equals negative 2/3. Then we have our two tables where we put the domain in between negative infinity and negative 1, and so on and so forth, and the same thing on this side. And we put zeros, and we put the signs of our derivative and the signs of our second derivative. When is f both concave up and decreasing? So we had to combine these two tables, put the points of negative 1, negative 1/3, and negative 2/3 on the table, put the domains in between each one, and then we put down what we know. So we put down the zeros, and then the domains like negative to infinity and negative 1, we already know that this is positive, so we put in everything that we know. And one thing is that in the gaps that we didn't know, like for these two domains, or these two domains and negative 2/3, the signs cannot change. So, or since that it was negative, since it's negative in between, or we know that it was negative in between negative 1 and negative 1/3, this is negative 1, this is negative 1/3. We know that this whole stretch right here is negative. And then it's the same thing down here. We knew these two, but we didn't know this. But the sign can't just change. So the rest of this is positive, and then the rest of this is negative. And then now we just look, when it's concave up, f double prime has to be positive, so it's positive on these 3 points. And when it's decreasing, f prime has to be negative. So this is the only part where f prime is negative and f double prime is positive. So f is both concave up and decreasing on the domain negative 2/3 to negative 1/3. Speeding up or slowing down. An object is speeding up if v of t and a of t, or velocity and acceleration, have the same sign. An object is slowing down if velocity and acceleration have different signs. 2. A particle is moving along the x-axis with position function x of t equals 1/3 t cubed minus 4t squared plus 12t. Find the velocity and acceleration functions to describe the motion of the particle. So our velocity function is just the derivative of our position function. And then our acceleration function is the derivative of our velocity function. Now, when you find when these equal 0, you'll find that t equals 6 and 2, and right here t equals 4. Since these are both positive, the motion of the particle is speeding up. For the given function f of x, f prime of x, and f double prime of x do not change signs. A table of values for f of x is given on the table below. Is f of x increasing or decreasing? This is easy because we could literally just look at our values and see that they're increasing. Is f of x concave up or concave down? Now, since we know that we have to figure out concavity, we have to know the double prime, but we know that the signs does not change. So that means f double prime is positive, which also means that it is concave up.